What are stars made of? It sounds like a simple question, something even a child might ask while staring up at the night sky. But for most of human history, nobody truly knew. Scientists could measure the light from stars. They could map the sky. They could name constellations, track planets, and calculate motion with stunning precision. But one mystery remained untouched. What is actually burning inside those distant suns? And the reason we know the answer today is because of a young woman who dared to trust data over authority. Her name was Cecilia Payne, and without her, modern astronomy might have taken much longer to understand the universe at all. Cecilia Payne was born in England in 1900. She was brilliant, deeply curious, and drawn to science. At a time when women were rarely welcomed into serious academic life, she studied at Cambridge, one of the most famous universities in the world. But there was a cruel catch. At that time, women could study there, but they were not granted full degrees. Imagine doing the same work as everyone else, mastering the same ideas, passing the same standards, and still being told you did not fully belong. That was the world Cecilia entered. So she crossed the Atlantic and went to Harvard. There, she found something that would change science forever. Astronomers had already begun using a powerful new tool called spectroscopy. Every star gives off light, and when that light is split into a spectrum, it reveals dark or bright lines, almost like a hidden barcode. Those lines carry information about the elements inside the star. To most people, starlight looks beautiful. To Cecilia Payne, it looked like evidence. It looked like a message waiting to be decoded. At the time, many scientists believed that the sun and stars were made of roughly the same elements as Earth. That seemed reasonable. After all, Earth was the only place humans knew directly, so they assumed the universe was built from the same kind of material. But Cecilia looked at the data more carefully. She studied the spectral lines and applied the physics of ionization, especially ideas developed by Indian physicist Meghnad Saha, and she reached a conclusion that was so radical, so shocking, that it seemed almost impossible. The sun was not mainly made of iron. It was not mostly like Earth at all. Instead, Cecilia Payne argued that hydrogen and helium were overwhelmingly dominant. In other words, the universe was not built like our planet. Our planet was the exception. The stars, and likely most of the cosmos, were made of something far simpler and far more abundant. Today, that sounds normal. We teach it in schools. We mention it in documentaries. It feels obvious, but at that moment, it was intellectual dynamite. In 1925, Cecilia published her PhD thesis. It has since been called one of the most important doctoral theses in astronomy. But when she first presented her conclusion, the scientific establishment resisted it. One of the most respected astronomers of the era, Henry Norris Russell, strongly doubted her result. The idea was too disruptive, too far from accepted belief, too uncomfortable, and so Cecilia was pressured to soften her claim. She was effectively told not to state her own discovery too strongly. Think about that. She had followed the evidence. She had done the mathematics. She had seen the pattern in the stars. But because the answer challenged scientific dogma, her confidence had to be reduced for the comfort of others. And yet, truth has a stubborn habit. A few years later, more evidence came in. More analysis was done, and the conclusion became unavoidable. Cecilia Payne had been right. The stars really were made mostly of hydrogen and helium. The composition of the universe had been revealed, and the person who first saw it clearly had been a young woman, whom the system tried to silence. This is why Cecilia Payne matters so much. Not only because she discovered something extraordinary, but because she represents a deeper principle. Data does not care about status. Truth does not ask permission from authority. That idea reaches far beyond astronomy. How many times in history has progress been delayed because someone powerful could not? Imagine being wrong? How many discoveries were dismissed, not because the evidence was weak, but because the messenger was inconvenient? Cecilia's story is not just about stars. It is about courage in the face of intellectual pressure. She did not have a giant lab of her own. She did not begin with social power. She did not fit the image of who science expected to lead a revolution. But she had something stronger. She had the ability to look at reality without flinching. That is what made her dangerous to old assumptions. And that is what made her indispensable to the future. Because once we understood what stars are made of, astronomy changed. Suddenly, stars were not just points of light. They became physical objects with chemical identities, life cycles, and internal structures. That knowledge became the foundation for astrophysics as we know it. It shaped how we study stellar evolution, how we understand galaxies, how we model the birth and death of stars, how we interpret the light from distant worlds. Even today, when telescopes like the James Webb Space Telescope analyze ancient galaxies and atmospheres of exoplanets, they depend on the same basic logic Cecilia helped establish. Light carries information, patterns reveal structure, and if we decode them correctly, the universe tells us what it is made of. That is an astonishing legacy. A woman in the early 20th century, told to step carefully, ended up changing how humanity reads the cosmos. She saw the code in the stars, and maybe that is the most beautiful part of this story. Because Cecilia Payne did not touch the sun, she did not visit a star. She did not need a spaceship. She used intellect, discipline, and honesty to reach across impossible distance and tell us, for the first time, what the universe is really built from. That is science at its most powerful. Not just machines, not just equations, but the refusal to lie about what the evidence says. Cecilia Payne later became the first woman to be promoted to full professor at Harvard's Faculty of Arts and Sciences, a milestone that should have come much sooner. Recognition arrived, but slowly, as it often does for unsung heroes. And that is exactly why we need to remember her now. Because history is not only shaped by the loudest names. Sometimes the people who change everything are the ones who quietly read the signal before anyone else. The ones who notice what others ignore. The ones who keep going when authority says no. The ones who trust truth enough to stand beside it, even when they must stand alone. Cecilia Payne was one of those people. So the next time you look at the night sky, remember this. The stars are not just beautiful, they are readable. And one woman, nearly a century ago, taught humanity how to read them honestly. Not by following tradition, not by pleasing power, but by listening to the evidence hidden in light. That is why Cecilia Payne is not just an astronomer. She is one of the great unsung heroes of human knowledge. And in a world still crowded with noise, dogma and ego, her message remains as bright as the stars she studied. If the data speaks clearly, have the courage to hear it.